Alka Agarwal, second year BA program student, is here elated to present her research paper on the topic NSDP per capita and PM 2.5, unveiling the trade-off between economic growth and air quality in Delhi from 1993 to 2023 for 3 decades. And here NSDP per capita is used as a measure of economic growth, while PM 2.5 is used as a measure of air quality. And the objective of this paper is to analyze if Delhi's NSDP per capita impacts PM 2.5 concentration and to what degree. And the significance is to help policymakers make informed and rational decisions, balancing economic growth with environmental sustainability. And the key concepts used here are economic growth. Economic growth. It refers to the increase in production of goods and services in the economy over a period of time, and it's typically measured by the rise in a country's GDP or NDP. And here I have used NSDP per capita. This is a measure of total value of goods and services produced within the boundaries of a state, and here it's Delhi during a specific period adjusted for the depreciation. And here the best prices used are 2011-12. NSDP per capita is the average economic output per person. Air quality, this refers to the condition of air in a specific area based on the presence and concentration of pollutants. And the PM 2.5 concentration is an air quality indicator. This is a particulate matter with the diameter of less than 2.5 micrometer, which is small enough to be inhaled and causing severe respiratory and cardiovascular diseases. And the hypothesis or the basis of the research paper is environmental Kuznets EKC. The hypothesis by Simon Kuznets in 1955 suggests pollution rises with economic growth initially, but decreases after a certain income level. And this chart suggests that economic growth increases, but there is a positive relation causing increase at the initial level and causing decrease at the afterwards. Reaching a specific income level. And the OLS equation has been used to quantify the linear relationship between these variables. And the Pearson correlation is used to measure the strength of association between these variables. And this is the inverted U-shaped DKC curve suggesting the correlation between income levels and environmental degradation. And these are the major component of the study. NSDP per capita and PM 2.5 concentration has been used to show the trade-off between economic growth and air quality in Delhi using linear regression model through the OLS estimator. And the data and data sources used here are, for NSDP per capita, I have used the Ministry of Statistics and Program Implementation of Government of India. For PM 2.5 concentration, I have used Income Tax Office Department till 2006 data, and afterwards I have used the data of Central Pollution Control Board and Delhi Pollution Control Committee. And the time frame is 1993 to 2003 for 3 decades. And the methodology explains here the annual trend analysis of NSDP per capita and PM 2.5 concentration, and the statistical correlation between these variables. And the regression model has been created using OLS estimator.
The NSS data, from Moscow you have taken NSS data.
NSS?
Which data source you have taken from Moscow? That is the website, right?
Oh yes.
So what data you have taken?
NSDP per capita.
You can.
And the methodology here explains the annual trend analysis and the statistical correlation, and then I have created regression model, and then I have checked the model fit using R value, Pearson's coefficient, and R squared value, coefficient of determinants, and significance test like T value and P values. And this is the data showing the NSDP per capita and PM 2.5 over the 3 decades. And now I will explain trend analysis. For the NSDP per capita, we have encountered continuous growth over the 3 decades in Delhi. The NSDP per capita has increased from 64,200 rupees in 1993-94 to 2,58,941 rupees in 2022-23. And the average NSDP of these 3 decades is 1,62,007 rupees. And however, there is a sharp decline during 2021 due to COVID pandemic and the lockdown. And in the PM 2.5 concentration, we have seen severe fluctuations, and however, overall it has declined in this time period. From it was average 136 during the 1993-4, and it was about 100 in 2022-23. And the average PM 2.5 of this decade, of the 3 decades, is 132.19 microgram per meter cube. And the major peaks have been seen during 2006-15 due to rapid industrialization and vehicular emissions. Our observation is that we have observed economic growth with gradual air quality improvements in Delhi. And this has shown that the NSDP per capita has continuously increased till 2020-21 till the period of COVID-19 pandemic and the lockdowns. And after that, it has also started showing the positive increasing trend again. And this is showing the that there is severe fluctuations in PM 2.5 concentration in Delhi over these decades, and however at the overall level it has decreased from 1993-4 to 2023.
One more minute. In that time. Carry on. Carry on.
And now I will show the overall result, the regression model result which I have encountered and observed. The equation that come out from this data is PM 2.5 equals to 148.73 minus 0.00013374 multiplied by NSDP per capita. This is showing that the NSDP per capita is increasing. When NSDP per capita is increasing by 10,000 rupees, PM 2.5 concentration is decreasing by 1.34 microgram per meter cube. And the R value here is minus 0.4987, showing moderate negative correlation. And the R squared value coefficient of determination is showing 24.87 variance is explained in the PM 2.5 by the NSDP per capita. And the P value is 0.00503, showing statistically significant relationship between these variables. And the T value is minus 3.0445, large enough to show a strong significance. And the residual standard error indicates the model's accuracy. And this is the overall regression line which I have observed, that there is negative correlation, and this is the negative slope line. And now I will discuss the literature review and the result what it has suggested us. The result finds are that there is negative correlation between economic growth and air pollution in Delhi over this 3-decade period. This aligns with the EKC hypothesis, where pollution levels declines after a certain level of economic development is achieved. It is important to note in starting 3-4 years PM 2.5 is increasing. So it is also showing during the 3-4 period that there is positive relationship. But at the overall level and in the majority of years, it is decreasing. That's why that was just a negative slope line, not a inverted U-shaped curve. Until that, there are 3 types of finding which has been encountered regarding EKC curve. In the support of inverted U-shaped EKC, the findings that I have encountered in my case. Hibol et al. 2017 found a correlation between NO2 pollution and economic growth in various states and union territory of India. This has shown that pollution has increased in early stages of growth in 2000s, but later in 2012 it declined due to improved technology and regulations. And Jiang et al. 2020 found similar results in China and South Korea, where metropolitan areas exhibited an inverted U-shaped EKC pattern, similar to Delhi. However, this study found U-shaped EKC curve in non-metropolitan cities. In support of U-shaped EKC, there are also studies which show that there is the correlation between pollutants and economic growth shows U-shaped curve. Orbu et al. 2011 explored the relationship between per capita income and environmental degradation in Africa. His results showed that while the EKC was valid for suspended particulate matter, but it was not observed for organic water pollutants. which continue to increase with economy. This implies that the EKC's applicability varies by pollution type, making it less generalized. And there are some studies which show that there is no correlation between economic growth and environmental pollution in certain cases. Like the study of Chang et al. 2017 analyzed the link between gross regional product and gross regional product per capita and air quality in China. Their findings revealed no direct relationship between GRP and three main pollutants, contradicting the EKC. However, they observed an inverse U-shaped relationship with secondary industry and a U-shaped relationship with tertiary industry, challenging the EKC's validity. And now the implication which this result shows is, like to sustain this negative correlation, we need to imply and continue the environmental policies and environmental regulations. So we need to still invest in green infrastructure, strengthen our regulatory frameworks, promote cleaner technologies, should expand public transportations and emission norms, incentivize this renewable energy adoption, improve air quality monitoring systems. The final key takeaway from this study is that there is inverse relationship between economic growth and air quality in Delhi. The higher NSPP per capita is lowering the PM 2.5. However, this is only happening with better technology and regulations. And the future research directions and the limitations of my study is this must include other factors like traffic and industries. I have tried over that, but the data shows no significant correlations. That's why I have not included it in the paper. And we can use linear model for deeper insights and can incorporate meteorological conditions showing seasonal fluctuations. Can analyze sector-specific pollution impact like in secondary sector or in tertiary sector.
Alka, go back to the previous point. What did you